Hello, my name is Swastik Patsarkar, and the problem that I am going to discuss today in this data structures and algorithm series is binary search. Binary search is a very famous algorithm used in searching a particular element or item into a given list. It is quite efficient when the number of items or the size, say, into a population of people. We want to find the identity of one person, and the list goes on in increasing order. Then binary search helps us in divide that list into two parts and search the element or the identity in our example, or find its location by making it simple, and also neglecting the part that is not needed. Means if there is more chance of getting an element on one side, then we can ignore the other side. So now let us see how it happens. Suppose we are given the element into an array that is 2, 4, 7, 9, 13, 18, 25. Then we need to calculate element, that is mid element, which is the key in dividing it in left and right, or we can say the lower half and higher half, or left or right. What we do is, every time we make branching or the separation, it is made on the basis of mid element. Suppose our mid one is 9, because adding 0 plus 6, we use a calculator. If we do 0 plus 6, that is 6 divided by 2, then we get the index 3, that is 0, 1, 2, 3. So our new mid will be 9. And we will compare our target element, that is 18. So 18 is greater than 9, so we'll move on to the right side, or to the higher order, or to the increasing order. So we will move to right. Similarly, if our target was, let's say, 7, so we would have moved to left. But for moving left, we would need to calculate the newer mid each and every time, in order to make a branching or the separation point. And if it was so, then our lower would be mid minus 1, or else it was mid plus 1. And doing so, applying binary search every time into a searching technique, the time complexity becomes big O of log n, instead of having big O of n in its worst case. Now, after seeing this theoretical part, let me move on to programming. Here is a sample array given. Into the sample space, having total element about 9 and our target is 40. Now we want to find is 40, means we want to find its location or index, or our function must return the index at which that element is present, or our target element is present. Let me write to it. We need to declare int low equal to 0, means it is at 0's index initially, and int high, that is arr dot length. and our this loop will go on till we move towards the higher elements, that is low is less than or equal to high. This we will generally move from left to right based on our while loop, and based on this primary logic we will return our target or mid if found, that is ARR of mid is equal to target. Here the variable mid is the updated index at which we are about to find the given element of target, that is number 40. If we have found it in first search in between, then we must return. If element is at first iteration found, then it is a best case, then we will return mid, or else if ARR of mid is less than target, then we will return our low is equal to mid minus 1, or else return mid plus 1, or new low equals to mid plus 1. This is because we know that if we are at the mid, then on the left side the elements would be in would be smaller, and on moving on the right side in ascending order the elements would be of higher values. The primary condition that can be of returning minus 1 as default if no element is found, and into our input we are only giving positive integers, so this negative minus 1 will imply that no element has been found. And then let me okay, the error is because I haven't calculated mid. So every time we make separation or branching through an element that is mid, then we need to always calculate it, that is low plus high divided by 2, and run. ARR dot length minus 1, I think. Now should it work? Yes, on the index 0, 1, 2, 3, 4. On fourth index we have found the element. For more clarification, what might have happened that in this our basic example 18. So by calculating every time the new mid calculation, we can find the number 18 because 6 plus 3 in our last mid calculation, if you do it, suppose 3 plus 6 equals to 9, then divided by 2, we will get 4.5. And this 4.5 uh, is not an integer value, so it will directly assume it as the index 5. So after rounding off we will get the value that is 18. This can happen and give us a more exact and probable reason in order to find our element into a given list that is sorted. So what I have learned is that if we have a sorted list, uh, in our example of population of people based upon their date of birth, we can arrange their data into an increasing order, and finding uh, the identity of particular person may get uh, easier if we apply binary search or any more optimized version of it. So that's it for the day. I will be making video on upcoming topics and will be having a self review in improving my programming logic and also the speaking skill. Till then, thank you, bye bye, and have a good day.